Have you ever wondered what makes your smartphone smart? Or how your video game console can create entire worlds on your screen? The answer lies in something incredibly small but powerful. These are called semiconductors, or more commonly, computer chips. Think of them as the tiny brains inside every electronic device you use. They are the fundamental building blocks of our modern world. Without these little pieces of engineered sand, the technology we rely on every single day simply would not exist. From the moment you wake up to the moment you go to sleep, these chips are working silently behind the scenes to make your life easier, more connected, and more entertaining. These chips are not just in your phones or computers, they are in your family's car, helping the engine run efficiently and keeping you safe with features like airbags. They are in the traffic lights that manage the flow of cars on the street. They are even in your refrigerator, helping it maintain the perfect temperature to keep your food fresh. A semiconductor is a material that can control the flow of electricity. It acts like a switch, a gatekeeper for tiny electrical currents. By turning these switches on and off billions of times per second, these chips can perform complex calculations, store information, and run the software that powers our digital lives. They are the heart of all modern electronics. The story of semiconductors is a story of incredible human ingenuity. It is a tale of scientists and engineers who figured out how to etch billions of microscopic transistors onto a tiny sliver of silicon, a material made from common sand. This process is one of the most complex and precise manufacturing feats ever achieved by humanity. It requires factories that are cleaner than hospital operating rooms and machines that cost hundreds of millions of dollars. The journey from a grain of sand to the powerful chip in your pocket is a long and difficult one, involving a global supply chain that spans continents and connects the economies of many different nations. In this essay, we will explore the fascinating world of these essential components. We will start by understanding what semiconductors are and why they are so important. Then, we will look at how they are made, a process so difficult that only a few places in the world have mastered it. A major focus will be on the global landscape of chip production, and specifically, the incredible rise of China as a dominant force in the technology industry. We will examine how China strategically positioned itself to become a key player in this critical field, a development that is reshaping the global economy and the future of technology for everyone. At its core, a semiconductor is a special type of material. Its name gives us a clue about what it does. The prefix semi means half, so it is a half conductor. To understand this, think about materials that conduct electricity. Metals like copper are excellent conductors. Electricity flows through them very easily, like water through a wide-open pipe. On the other hand, materials like rubber or glass are insulators. They block the flow of electricity completely, like a sealed cap on the pipe. A semiconductor is unique because it can act as both a conductor and an insulator. It can be switched between these two states, allowing us to control the flow of electricity with incredible precision. The most common material used to make semiconductors is silicon. Silicon is the second most abundant element in the Earth's crust, found everywhere in sand and quartz. On its own, pure silicon is not a very good conductor. The magic happens when we introduce tiny, controlled amounts of other elements into it, a process called doping. By adding impurities like phosphorus or boron, we can change silicon's electrical properties. This doping creates areas that either have an excess of electrons, which is a negative charge, or a shortage of electrons, which is a positive charge. This ability to precisely manipulate the electrical properties of silicon is the foundation of all modern electronics. This control allows engineers to create microscopic switches called transistors. A transistor is the most basic element of a computer chip. It is a tiny gate that can be opened or closed to either allow electricity to pass through or to stop it. When we apply a small electrical voltage to the gate, it switches its state. Think of it like a light switch on the wall. When you flip the switch, you complete a circuit and the light turns on. A transistor does the same thing, but it is millions of times smaller and can be flipped on and off billions of times every second. A single modern chip can contain billions, or even tens of billions, of these tiny transistors. The ability to pack so many of these switches onto a small piece of silicon is what gives computer chips their incredible power. Each on or off state of a transistor represents a piece of digital information, a 1 or a 0. This is the binary code that computers use to think. By combining billions of these simple on-off signals, chips can perform the most complex tasks imaginable. They can run operating systems, process images, connect to the internet, and execute the instructions of any software program. The simple act of controlling electricity in a special material like silicon is the fundamental principle that has enabled the entire digital revolution. It is easy to think of semiconductors as something hidden away inside computers and phones, but their influence extends far beyond our personal gadgets. They have become an invisible, essential part of the fabric of our everyday lives. Consider the car your family drives. A modern vehicle is like a computer on wheels, containing dozens, sometimes over 100 different chips. These semiconductors control everything from the engine management system, which optimizes fuel efficiency and reduces emissions, to the anti-lock brakes that help you stop safely in an emergency. They also power the infotainment system, the GPS navigation, and the advanced driver assistance systems that warn you if you are drifting out of your lane. Think about your home. The smart devices that are becoming more common all rely on chips. A smart thermostat learns your schedule to save energy on heating and cooling. A smart speaker listens for your voice commands, and a chip inside processes the sound, connects to the internet, and delivers your answer. Even older, more traditional appliances now contain semiconductors. Your microwave oven uses a simple chip to control cooking times and power levels. Your washing machine has a chip that manages the different wash cycles, water levels, and spin speeds. These chips make our appliances more efficient, reliable, and user-friendly than their older mechanical counterparts. The importance of semiconductors becomes even clearer when we look at the larger systems that our society depends on. The entire global financial system runs on vast networks of computers and data centers, all powered by high-performance chips. Every time you use a credit card or withdraw money from an ATM, semiconductors are processing that transaction securely and instantly. Our healthcare system is also deeply reliant on this technology. Advanced medical equipment like MRI scanners, digital X-ray machines, and patient monitoring systems all use sophisticated chips to function. These devices allow doctors to diagnose illnesses with greater accuracy and save lives. Even the food we eat and the electricity that powers our homes are connected to semiconductors. Modern farming uses GPS-guided tractors and sensors that monitor soil conditions, all of which contain chips to help farmers increase crop yields and use resources more efficiently. The power grid that delivers electricity to our communities is managed by complex control systems that use semiconductors to balance supply and demand, preventing blackouts. From the largest infrastructure projects to the smallest household items, semiconductors are the silent partners that enable the convenience, safety, and efficiency of our modern world. Without them, society as we know it would grind to a halt. Creating a computer chip is one of the most technologically demanding and expensive manufacturing processes in the world. It begins with a raw material, silicon, which is refined from common sand into large, perfectly cylindrical crystals called ingots. These ingots, which are over 99.9999999% pure, are then sliced into very thin, perfectly flat discs called wafers. A single wafer, typically about the size of a dinner plate, will eventually become the base for hundreds of individual computer chips. The entire process from this point forward must take place in an environment far cleaner than a hospital operating room, known as a clean room. Inside the clean room, the air is filtered continuously to remove even the tiniest particles of dust, skin, or hair. A single speck of dust is like a giant boulder compared to the microscopic circuits being built on the wafer, and its presence could ruin an entire chip. Workers in these facilities, called fabrication plants or fabs, must wear special head-to-toe suits, often called bunny suits, to prevent any contamination. The manufacturing process itself involves hundreds of distinct steps, repeated in cycles. The main technique is called photolithography, which works a bit like developing a photograph. It uses ultraviolet light to project a microscopic circuit pattern onto the silicon wafer, which has been coated with a light-sensitive chemical. After the pattern is projected, a series of chemical processes etches the circuit design into the silicon wafer, layer by layer. This involves adding and removing different materials, creating the billions of transistors and the intricate network of copper wires that connect them. This entire cycle of photolithography, etching, and depositing materials is repeated dozens of times to build up the complex, three-dimensional structure of the chip. The features being created are astonishingly small. The most advanced chips today have transistors that are measured in nanometers. A nanometer is 1/1000th of a meter. To put that in perspective, a single human hair is about 100,000 nanometers thick. Once all the layers have been built, the wafer is tested to see which of the individual chips on its surface are working correctly. The wafer is then cut up or diced into hundreds of separate chips. The good chips, known as dies, are then sent to another facility for packaging. This final step involves enclosing the fragile silicon die in a protective casing, usually made of plastic or ceramic, and attaching the tiny metal pins or pads that will connect it to the circuit board of a larger device, like a smartphone's motherboard. This incredibly complex and lengthy process explains why building a cutting-edge fab can cost over $20 billion and take years to complete. The immense complexity and staggering cost of semiconductor manufacturing mean that very few countries in the world have the ability to produce the most advanced chips. The industry is not something a nation can simply decide to enter. It requires decades of accumulated knowledge, a highly skilled workforce, and enormous sustained investment. The equipment needed for a modern fab is itself a modern marvel. For example, the photolithography machines that project the circuit patterns onto the wafers are made by just one company in the world, ASML in the Netherlands. A single one of these machines costs over $200 million and is so large it has to be shipped in multiple jumbo jets. This has led to a highly specialized and deeply interconnected global supply chain. Different countries and companies excel at different parts of the process. The United States, for instance, is a leader in chip design. Companies like NVIDIA, AMD, and Qualcomm design some of the world's most powerful chips, but they often do not manufacture them. This is known as the fabless model. The actual manufacturing of these advanced designs is dominated by a handful of companies, primarily in Asia. The undisputed leader in this area is Taiwan Semiconductor Manufacturing Company, or TSMC, in Taiwan, which produces over 90% of the world's most advanced logic chips. South Korea is another giant, with Samsung being a major force in both memory chips and advanced logic manufacturing. This concentration of production in just a few locations creates significant risks for the global economy. A natural disaster like an earthquake in Taiwan or a geopolitical conflict could disrupt the supply of these critical components, causing a ripple effect across countless industries worldwide. We saw a preview of this during the COVID-19 pandemic, when factory shutdowns and a surge in demand for electronics led to a global chip shortage. Car manufacturers had to halt production lines, and prices for electronics soared. This vulnerability has made governments in the United States, Europe, and Japan realize that they need to bring more chip manufacturing back to their own shores for economic and national security reasons. However, catching up is incredibly difficult. It's not just about building the factories. A country also needs a complete ecosystem to support them. This includes a reliable supply of ultra-pure chemicals and gases, a workforce of thousands of specialized engineers and technicians, and a network of companies that can supply and service the complex machinery. Furthermore, the technology is constantly advancing. A state-of-the-art fab today will be outdated in just a few years. This constant race, known as Moore's Law, means that any country trying to enter the field is aiming at a moving target, requiring them to invest billions of dollars continuously just to keep pace with the leaders. For decades, China has been known as the world's factory. It built its economic miracle on manufacturing clothing, toys, and simple electronics for the rest of the globe. However, over the past 20 years, China has embarked on an ambitious journey to move beyond low-cost assembly and become a true technology superpower. The country's leaders understood that to be a dominant force in the 21st century, they needed to control the technologies of the future. This meant moving up the value chain from simply putting together products designed elsewhere to designing and building their own high-tech products, including the semiconductors that power them. This transformation has been remarkably successful in many areas. Today, China is home to some of the world's largest and most innovative technology companies. Think of giants like Huawei, which became a global leader in telecommunications equipment and smartphones. Or consider Tencent, the company behind the super app WeChat, which combines messaging, social media, and payments for over 1 billion users. Another example is Alibaba, a massive e-commerce and cloud computing company often compared to Amazon. These companies are not just copying Western technology, They are innovating and creating new business models that are being adopted around the world. China's dominance is also clear in emerging technologies. The country is the world's largest market for electric vehicles and is home to leading EV manufacturers like BYD, which now sells more electric cars than Tesla. In artificial intelligence, Chinese companies are at the forefront of developing applications for facial recognition, smart cities, and autonomous systems. This rapid technological rise was not an accident. It was the result of a deliberate national strategy, supported by massive government investment, a focus on science and engineering education, and a protected domestic market that allowed its homegrown companies to grow strong before competing globally. This broader technological strength forms the backdrop for China's ambitions in the semiconductor industry. Chinese leaders recognize that their booming tech sector was built on a fragile foundation, a deep dependence on foreign-made chips, primarily from the United States, Taiwan, and South Korea. To secure their technological future and reduce their vulnerability to outside pressure, they made achieving self-sufficiency in semiconductors a top national priority. This set the stage for a massive state-led effort to build a domestic chip industry from the ground up, an effort that has become one of the most important stories in global technology and politics today. China's push into semiconductors is not just a commercial endeavor, it is a national mission, driven from the very top of its government. Recognizing their Achilles heel, the reliance on foreign chips, Chinese leaders launched a series of ambitious industrial policies. The most significant of these was the Made in China 2025 plan, which explicitly identified semiconductors as a critical industry where the country needed to achieve self-reliance. To fund this goal, the government established massive investment funds, often called big funds, which have poured tens of billions of dollars into building new fabs and supporting Chinese chip design companies. This government support has taken many forms. It includes direct subsidies to companies, low-interest loans, and tax breaks. The state also plays a key role in coordinating the efforts of different companies, universities, and research institutes to avoid duplication and focus resources on breaking through key technological bottlenecks. This strategy has led to a huge boom in construction. In recent years, China has been building new semiconductor fabs faster than the rest of the world combined. While many of these fabs initially focused on producing older, less advanced chips, known as mature nodes, they have steadily been working to master more complex manufacturing processes. Another key part of China's strategy has been to acquire talent and technology from abroad. The government and private companies have offered very high salaries and attractive benefits to lure experienced semiconductor engineers from places like Taiwan and South Korea to come work in China. This has helped to accelerate the transfer of know-how and expertise. At the same time, Chinese companies have attempted to acquire foreign technology firms, although many of these efforts have been blocked by governments in the United States and Europe due to national security concerns. This has forced China to redouble its efforts on developing its own homegrown technologies. The results of this national push are now becoming clear. While China still lags significantly behind the global leaders like TSMC and Samsung in producing the most advanced chips, those below 7 nanometers, it has become a dominant force in the market for mature node semiconductors. These are the chips used in cars, home appliances, and industrial equipment. By flooding the market with these lower-cost chips, China is gaining significant market share and making the world more dependent on its supply chain. Companies like SMIC, or Semiconductor Manufacturing International Corporation, have become major national champions, representing China's best hope for eventually catching up to the cutting edge. The rise of China in the semiconductor industry has turned this technological competition into a major geopolitical issue, often referred to as the chip war. The United States, seeing its long-held technological leadership challenged and concerned about the military applications of advanced chips, has taken strong measures to slow China's progress. In recent years, the United States government has implemented a series of strict export controls. These rules are designed to prevent China from acquiring the advanced chip-making equipment, design software, and even the chips themselves that are necessary for developing cutting-edge technologies like advanced artificial intelligence and supercomputing. These controls have put immense pressure on Chinese tech giants like Huawei, which was effectively cut off from its supply of advanced chips, severely damaging its smartphone business. The rules also prevent companies like ASML from selling their most advanced photolithography machines to any factory in China. In response, China has accused the United States of trying to stifle its economic development and has doubled down on its quest for self-sufficiency. This has intensified the race, pushing China to invest even more heavily in its domestic semiconductor industry and to develop its own alternatives to American technology, creating a techno-nationalist response. This escalating competition is forcing other countries to choose sides. The United States has worked to align its allies, including Japan and the Netherlands, to adopt similar export controls, creating a united front to limit China's access to key technologies. Meanwhile, nations around the world are grappling with the reality of a potentially bifurcated technology world. Will there be one global standard for technology, or will there be two separate ecosystems, one led by the United States and its allies, and another centered around China? This has profound implications for every company that makes or uses technology. The future of the semiconductor industry will likely be defined by this intense competition. The United States and Europe are now pouring billions of their own government funds into building new fabs on their home soil through initiatives like the CHIPS Act. Their goal is to de-risk their supply chains and reduce their dependency on Asia. This new era is not just about which company can make the best chip. It is about which nation or bloc of nations will control the foundational technology of the 21st century. The outcome of this chip race will shape the global balance of economic and military power for decades to come. We have journeyed through the microscopic world of semiconductors, from the fundamental magic of silicon to the colossal factories that bring them to life. These tiny brains, these intricate switches, are far more than just components in our gadgets. They are the silicon heartbeat that powers the entire modern world. They are the enablers of communication, transportation, healthcare, and entertainment. The immense difficulty and cost of producing them have concentrated this awesome power in the hands of just a few key players, creating a delicate and vital global supply chain that our collective prosperity depends on. Into this established order, China has emerged as a formidable new force. Driven by a powerful national ambition to achieve technological sovereignty, China has transformed itself from the world's assembler into a burgeoning innovator. Its strategic state-led push into semiconductors is reshaping the industry. While it still faces significant hurdles in reaching the most advanced manufacturing nodes, its growing dominance in mature chips is already being felt across the globe. China's rise has turned the semiconductor industry into an arena of intense geopolitical competition, a chip war that will define the technological landscape for the foreseeable future. This new reality presents both challenges and opportunities. The global push to diversify supply chains, spurred by the United States-China rivalry, could lead to a more resilient and geographically distributed manufacturing base. However, it also risks fragmenting the global technology ecosystem, potentially slowing down innovation and increasing costs for everyone. The race for semiconductor supremacy is not merely a contest between companies. It is a competition between different economic and political models, with the control over the future of artificial intelligence, telecommunications, and military technology hanging in the balance. As we look toward the future, one thing is certain: the importance of semiconductors will only continue to grow. They are the essential resource of the digital age, as crucial as oil was to the industrial age. Understanding who makes these chips and who controls their supply is to understand the currents of power that will shape our 21st century world. The story of the semiconductor is the story of our time, a tale of incredible human ingenuity, complex global interdependencies, and the profound quest for technological dominance that will impact generations to come. The silent, invisible work of these tiny chips will continue to beat at the very heart